Okay, Math 2400, Lecture 14, Continuous Random Variables 2. So the CDF, Cumulative Distribution Function, is if x has some distribution with some parameters theta, with PDF fx, then the CDF, and let's assume that x is continuous. So the CDF of x is denoted by capital Fx, which is probability that x is less than or equal to x, and that is this integral. So I should have written that x continuous. So the PDF is continuous, and so that is in fact area under the curve from minus infinity to x, and this is the picture of that. And I say it again, I said last time that when we have continuous random variables, we do not talk about probability at the point. In fact, probability at the point, say probability that x equals x is 0. And okay, so let's see if we can find the CDF of some random variables when given fx. Now, before doing that, let's see how we can find PDF. So, finding PDF fx given CDF fx. But if you look at this, fx is from minus infinity to x ft dt, and this is a nice continuous function, and by fundamental theorem of calc ftc, df by dx is f of x, right? df dx is f of x. So if we are given the CDF, and we know that the the random variable is continuous, by finding the derivative of fx, we have the PDF. Okay, so let's see. Now, what kind of random variables did we have? And what examples did I give you last time? If I remember correctly, that was uniform. So let's do example. Remember the uniform random variable that was 0 everywhere, and then suddenly it was between a and b, it was 1 over b minus a. Okay. So, now you might say this is not continuous, you're right, but it is piecewise continuous. Okay, so that also works for piecewise continuous. It's continuous here, then jump, continuous here, then continuous here. So let's see. What is fx? Fx is in fact fx is 1 over b minus a for x between a and b, and 0 otherwise. So fx will be what? Is integral from minus infinity to x ft dt. So what do we have here? If this x is less than or equal to a, so if x is less than or equal to a, let's say is 0, right, for x less than or equal to a. What happens to this when x is So if x is between a and b, then it is from a to x, ft dt, and you can find this. This will be simply x minus a. If x is bigger than a, less than or equal to b. You see, x can't be a, because then you have 1 over 0. And what happens after, when x is bigger than b? So, sorry, this is incorrect. What am I saying? This is x minus a over b minus a. This goes here. Ah, gee, I'm making stupid mistakes. So that is x minus a over b minus a, and let's see. So let's write it here. So what happens when it is? How should I write it? Well, let's erase this thing. That's okay. So erase this and. So it is minus infinity to x ft dt. Well, it will be 1 for x bigger than b, right? So for x bigger than b, what is it? It's the area under this. The area under this plus the rest is 0. So I will get 1. So I can say that this is in fact something like this. So let me write down the CDF for this random variable. It is 0 for x less than or equal to a. It is x minus a over b minus a for x between a and b, and it is 1 for x bigger than b. So it basically looks like this. 0, 0, 0, 0, 0, 0 up to a, then goes up and goes to 1, and it's like this. And this starts with b. Right? So, by looking at this, we can come up with some general idea about certain things. First of all, if we have some nice and say piecewise continuous, we will get something continuous here. No, well, it's not differentiable at these 2 points where there were discontinuities. But first of all, it is 0 as x goes to negative infinity, and it's 1 as x goes to positive infinity. Let's look at this in a more mathematical way than just looking at this example. But this is a nice, and as I said, the uniform distribution is the simplest example. So let's look at the formula and see what we can get. So we had fx was from minus infinity to say x ft dt. Now we have 2 things here. First of all, limit as x goes to negative infinity. What happens as x goes to negative infinity of this thing? First of all, if x goes to negative infinity, remember this, for this integral, you have to choose something here like b and let b go to negative infinity. So these two basically they're matching. So, and we can take them to be the same. And so this will be 0. This is like 0. And you can tell intuitively this is 0. The other one, positive infinity. That is, in fact, the definition of ft is a PDF. So this is like from minus infinity to positive infinity ft dt. Remember, that was part of the definition of PDF, that this is 1. So these are the two important properties of the CDF. Now, in higher, say, in probability theory, you define fx, CDF in fact. And we don't care what the PDF is at the beginning, but if really like this one, if it is continuous, if x is what we call continuous, then when you find the derivative of that, you will get PDF. Anyway, so, but that's not always the case. So let's look at another one, another example, and I can see that there is a nice example here. So, and also there are some other things regarding this. So, well, we said that fx is from probability that x is less than or equal to, say, let's say b. X. Then f of b definitely is p of x less than or equal to b, right? So f of a is also p of x less than or equal to a. But we know that p of x less than or equal to a plus p of x bigger than a is 1, right? These two are complements. These two complement events. This is event E. This is event complement of event E. Event E complement. And remember the probability of complements, when you add them, you will get 1. So what do I get from here? From this thing, I will get this formula. That, let's write it here, that p of x bigger than a is 1 minus p of x less than or equal to a. So that is 1 minus f of a. Okay? So this also gives me a nice formula for calculating probability of something between 2 points. So this gives me this formula. So what is that? P of x bigger than a less than b, then less than or equal to b. So that will be p of x less than b minus p of x bigger than a. Let me see. That is, well, let's see which one was yeah, that was correct. Yeah. So this should be this thing. Minus p of x less than or equal to a. So that is f of b minus f of b. Great stuff. Okay. So let me A, B. So this probability is this area minus this area, right? This area under this from negative infinity to B minus area under the curve from negative infinity to A. Now from negative infinity to b is f of b. From negative infinity to a is f of a. We can also write this as two events, and one of them is included in the other one. When you subtract, you're subtracting the probabilities. That is in fact what if f is in E and P of E minus F, in fact is P of E minus P of F. It's not always that, but if it is inside, and so this x less than or equal to A is inside x less than or equal to B, right? Because if x is less than or equal to A, then it's definitely less than or equal to B. So this event is included in this event. But anyway, I don't want to get too much into detail in that sense. So okay, let's see. Another example I can see from here. So example 2 or example. So it says that x is some distribution and f of x is 1/8 2 and 0 otherwise. Find the CDF. Okay. So, well, CDF is very easy, but except you see this thing is, well, let's try and graph it. So, it's 0 up to 0.0, then here it changes to, at 0 it is 1/8, say 1/8, and it goes up to, so at 2 it is 6 and 7/8, so it's something like that. So it's 0 here and 0 here. It's only non-zero from 0 to 2. Okay, so you have to divide this into 3 when x is less than 0, when x is between 0 and 2, and when x is bigger than 2. So f of x, which is integral from minus infinity to x ft dt, will be 0 if x is less than or equal to 0, right? That is 0. And it is the integral of this thing from minus infinity. In fact, there's nothing at minus infinity, so it's basically is non-zero starting at 0. So instead of minus infinity, I will write 0 because it's nothing here. Up to say x, and that 1/8 plus 3/8 t dt. Let me write here that x is bigger than 0, less than or equal to 2. And I know what happens after 2. You don't have to do anything. It's 1 for x bigger than 2. Remember, it should be 1 as x goes to infinity. And after 2, there's nothing. The integral on this area, on this region, gives you 0. So nothing is added to this. Okay, so let's find this integral. I think I have the answer here. X/8, 1/8 x plus 3/16 x squared. So that is, that is a nice and simple example. Next thing is well, since this is still used, I just give you an idea what this is talking about. So, percentile. Percentile is when we say 100p percentile. Would p belong to 0 and 1? So it can be like 50 percentile, 20 percentile, 25 percentile. So this is, I guess, the book uses some funny notation here. So it is 100p percentile. It uses eta of p is probability that x is less than or equal to 100p, in fact. So that is from negative infinity to this thing, which is eta of p. No, sorry. What I was saying, this is, in fact, this is a number. Eta of p is a number such that this happens. I'm just making myself confused. So that p is a number here. So this you should find. It is integral from minus infinity to eta of p of ft dt. Okay, so it's saying this. It's saying it's going backwards. In fact, it's saying, okay, if I am given, say, some probability, like 75% or 0.75, so I have to find this is eta of p, and this area is p. I usually don't work with percentiles, so okay. So that's nice to know that this. Well, you will see that in statistics, in fact. But anyway, so that is like the inverse in a sense. So it's saying, okay, we are given the probability, find that point on the x-axis such that that point gives you this probability. So the probability that x is less than or equal to this number is p. So p is in fact f of eta of p. Okay. Now one of these is median. So let me do median. What does the book use for the median? Is mu tilde. Okay. Tilde is the 50, I think it's 0.5. So mu tilde is minus infinity. Sorry, that's should go here. That's 0.5 here. Mu tilde ft dt. So it is a point on the x-axis. This should go mu tilde, such that this probability is 0.5. So it is now this is the median, and we know what mean is, but I haven't defined mean here. So let me define mean here and then compare with median. So that is in fact you have to solve this thing. So if ft is given to you, you find this integral for the and plug in that mu hat and minus infinity, and then solve for mu tilde. Sorry. Now, what is mean? Or expected value, or average, or whatever. Okay. Remember, for discrete distributions, expected value or mean was what? It was something like this. So you multiplied, so mu x would be, remember, over x, probably that x equals x. But what is it when it comes to continuous? This is in fact that f PMF. Remember, that was PMF. So it was sigma x x fx. Now this is for discrete. Well, continuous is what? In continuous, sigma becomes integral, right? So in continuous, sigma becomes integral. So for continuous, basically we have integral from minus infinity to infinity x fx dx. Okay? So for continuous random variables, that is mean. Now let me write it let me connect, or remember this one I said this is in fact the weighted, say, center of mass, or center of mass. So I related that to mechanics. Now, this one is maybe makes more sense if you remember from Calc 2. Let me write this. Okay. So I said mu x is this thing, integral minus infinity x fx dx. Now, what if I divide it by fx dx? This is 1, right? So I'm not doing anything. Well, what is this? Remember from Calc 1? No, Calc 2 in fact. That was if I had some curve, something, then this would be this x coordinate of center of mass. So center of mass, so that was like x bar was this thing, right? X bar was this thing. So this is in fact the x coordinate of center of mass. So it is x coordinate of center of mass of the region with rho equals 1. And rho was, you have to enter rho into this picture, remember? In fact, the rho cancels out. The rho cancels out, so I can just say rho can be just any constant. But it should be constant. If it's constant, it cancels out. So that's what we call centroid. When that rho is constant everywhere, that's we call centroid. So that's the x-coordinate of the center of mass, or centroid. And remember, center of mass was like where you could just concentrate everything. So in a sense, it's like everything is concentrated here. In a sense, you can. So that's an amazing way to identify, say, not amazing. One of the things that you really attach to a distribution, that is its center of mass, the center of mass of this region, and or expected value or mean or whatever. And it, in a sense, it's showing that how things are, how close they are to this point, in fact, right? So, not how close, how should I say that? It's where it's basically concentrated. There is more concentration than other places. So, let's find this for certain distributions. The one that I discussed was example was x was uniform b. So expected value of x or mu of x is integral from minus infinity. What in fact we have nothing. So x times 1 over b minus a dx. Okay, so I have 1 over b minus a times 1/2 x squared from a to b. So I have 1 over b minus a times 1/2 times b squared minus a squared. But b squared minus a squared is what? Is b minus a times b plus a. So the b minus a cancels and I will get 1/2 times b plus a. Okay, so and it makes sense. That is like 1/2 b plus a is like the midpoint. But that's not like, it's the midpoint of a and b. So it makes sense to be the midpoint. A and b, and this is 1/2, or a plus b over 2. Okay. Another thing that we discussed was variance and standard deviation. So variance was variance. So what did we have for discrete? Discrete, it was variance of x was what? Was sigma x squared fx minus sigma x fx squared. Remember that? And that was in fact e of x squared minus ex squared. So that's the same thing as in continuous. And remember, again, sigma becomes integral. So that is integral from minus infinity to infinity x squared of x dx minus integral minus infinity to infinity x fx dx. And again, this by definition is e of x squared minus e of x squared. So that is variance, and the sigma is the square root of radical variance. Now variance, you can I define variance in a different way. This is in fact what I derive for variance. And the same thing happens, the other definition also, that in fact gives you this thing. So let's write that definition using mu x. So variance was what? Was the expected value of x minus mu x squared. So variance is positive. If you expand this thing and use properties of the integral, you will get this. So you will get this. And so variance is a positive number, or let's say non-negative number, and the sigma square root of that is in fact sigma, standard deviation of x. Okay, so let's find variance of the uniform distribution. So example of that is uniform distribution. X is this. So what do I need? I need variance of x will be, I can write, which one should I, okay, so let's use this, x minus mu x squared. So that is in fact integral from a to b, this thing small x minus mu x times 1 over b minus a dx. You see what this is? This is in fact integral from minus infinity to infinity of x minus mu x squared times fx dx. So I have an x squared. Well, I can just bring this out. Let's just write b minus a. So I have from a to b and x squared dx, then minus 2 mu x a to b x dx minus or plus mu x squared. There's mu x squared or log of mu. Right. So, might say that. And this, this has x. So this one is 1 dx from a to b. Oh, yeah, I forgot that. That's important. B minus times b minus a. So anyway, let's see what we have here. We have, yeah, I should have written that. So let's see, we have 1 over b minus a. This one is 1/2 x squared x 1/3, sorry, 1/3 x3 from a to b minus 2 mu x, and that is times 1/2 b squared minus a squared, and plus mu squared x times b minus a. This one is not that easy. I mean, the other formula is much, at least to me, it's much easier to use that, because part of this will, you will see cancellations. So it's like wasting time doing it this way. So I have 1/3 b minus a power 3. Sorry, b3 minus a3. What was that? b3 minus a3 and and minus 2 mu x times b squared minus a squared plus mu x squared times b minus a. So there's this 2 also cancels with the 2, and so I hope I'm correct. So this one is b minus a times b squared plus ab plus a squared. This one is b minus a times b plus a, and there's also b minus a here. So the b minus a, b minus a, b minus a cancel out, and I will get 1/3 times b squared minus plus ab plus a squared plus b plus a, and times mu x. So that is minus in fact, and plus mu x squared. Now b plus a is 2. That's 2 mu x. So 2 mu x squared will give me 1 minus mu x squared. And so that is in fact 1/3 times b squared plus ab plus a squared minus mu x squared. I don't think this is not a nice formula, but let me see if the book has much nicer. I can see that. Well, anyway, so I think if I write this as 1/2 a squared plus b squared, I will get some cancellations or something comes out of this. But anyway, so that is how you calculate that. I leave that to you to calculate, and so that is the variance of uniform distribution. I should have started with this thing. That was much easier. E of x squared minus ex. So that would be 1 over b minus a integral from a to b x squared dx minus mu x was 1/2 b plus a squared. Right, so that would give me 1 over b minus a times this will be 1/3 times b minus a times b squared plus ab plus a squared, and this would be minus 1/4 times b squared plus 2ab plus a squared. So this b, a, they cancel out, and I have 1/3. That's the same thing, but except you see it's just in one shot. I don't have to go through all that pain. So when you simplify this, you will get the variance of the uniform distribution on AB. I can't remember, but I think there is a nice, when you put all these things together, you will get a nice formula for that. So, because I will get 4 and minus 3, so I will get a squared b squared 1, and then I have 4 minus 6. Oh yeah, okay. So that is 12. And I have 4b squared plus 4ab plus 4a squared minus 3b squared minus 6ab minus 6a squared, 3a squared. So 1, 1, 1. So this is b squared minus 2ab plus a squared over 12. Right? That is in fact b minus a squared over 12. Yeah, so I think that's correct. Okay, so let me stop, and I will start the normal distribution next time. So see you soon.